All right. Uh, can everyone hear me okay? Welcome everyone. Thanks for tuning in from wherever you are. My name is Jabril Oyetunji, and the title of this session is From Chaos to Consistency Building Reliable Environments with Packer and Terraform. Well, this talk was born out of some of the frustrations that Great and I both faced at work when we were trying to build environments in our respective jobs, and we realized we were having similar problems. So we did the logical thing and we came together and made a talk out of it. So, like I said, I'm Jubilee Tunji, an independent software engineer. Fancy way of saying I'm unemployed at the moment. And I'm joined by Great. He's an infrastructure engineer at Gala Games. So he'll be telling you a little bit more about himself during the demo. So to give you a bit more context about the talk, will be first we have to start at the beginning. And in the beginning, there was chaos. When we say chaos, we mean there's a lot to unpack when we say chaos because our environments were not exactly consistent, nor were they. We couldn't confidently say that when we deploy this is going to behave as we expect. So the area of inconsistency for us, aka pre-configuration management, there was little to no documentation. Version controlling was non-existent. Not that there were no manifest in Git, but the ones we are each using to deploy the infrastructure was not version controlled. How to reproduce, again, inconsistency because the existing infrastructure doesn't match up to the code that existed. How to reproduce, if it's inconsistent, it's really hard to reproduce. Automation, yeah, good luck with that. Is it deployed manually? Was there a script? And no, we neither of us really knew. For me, there was actually no automation at all, so which was really bad. And for Great, I'm not sure what kind of automation was in place, but I think we both agree that the automation was really hard. And how do you scale that? Add more people to the team, or what happens when someone leaves the company, or what happens when, in my case, when I leave? So yeah, this was how inconsistent our environments were. So where do we go from here? Well, the solution was Terraform and Packer. I think I speak for both of us when I say it's default to reach for any of these tools when we had these sort of problems. So you're probably going to hear a lot more about these tools in the sessions to come, but I'm going to give you a quick elevator pitch on what Terraform is. You know, Terraform is an infrastructure as code tool that allows you to define and provision your infrastructure in a declarative way. Declarative meaning you define the desired state rather than the steps to get to the desired state. Uh, it provides a common language for teams to communicate about infrastructure. A common language being HashiCorp configuration language. Everyone on the infrastructure team can agree that this is what we use to define our infrastructure, and this is how we go about it. Terraform allows you to manage your infrastructure in a consistent way, which is exactly why it's almost default at this point. It provides state management tools that allows you to reliably deploy your infrastructure. And now that we have a common language that we can use to define this infrastructure, we can also put this into Git. Moving along, we have Packer as well. So Packer is a tool that allows you to create machine images for multiple platforms from a single source, and it allows you to build machine images consistently. Again, these tools tie so nicely into like what we're trying to say here, which is reliably deploying and building your infrastructure so that what we write and what we deploy are consistent each time. And this is why we selected these tools. And I have a small example of what a Packer configuration looks like. So Great will be telling more about that in the demo to come. So does Terraform plus Packer equals magic or consistency? Well, yes, but actually no. The manner in which you leverage these tools will determine how much benefit you can get from them. And we have a few points or a few points that we'd like to share and how we achieved reliable environments. The first being consistency is key to success. So As I explained earlier, Terraform and Packer both allow you to reliably and reproducibly build infrastructure. Reducing the number of manual interventions you have in your build process would go a long way into determining how consistent your environments can be. I recognize this is different for everyone, as no two environments are the same, which is why I said reduce the number of manual interventions, because this can look different for any environment. Building intuitive CI/CD pipelines. This is also related to the point of reducing the number of manual interventions. CI/CD is to help automate the deployment of things, and when your CI/CD pipelines are intuitive, there's a higher chance that people would be more encouraged to push to Git or wherever your CI is running. If your CI pipelines are hard to use, nobody really wants to push something because they're scared that they might break the CI, or their change it's going to be hard to see their changes reflected. Automate everything you can. Again, this can look different for everyone, but as much as possible, you should try and automate anything you can, and document everything you can. Document everything you can't automate, and also document everything you can. Again, if I leave the company, what happens to the infrastructure I've built? Sure, it's running now, but someone else comes along, wants to make a change, or even tries to understand what's going on. It's going to be hard, and this is not good for consistency in the long term, because they might make a change, they might not document it themselves, or they do something that wasn't as intended. So documentation is actually a really huge part of being able to reliably deploy and produce infrastructure. So with that being said, it's time for the demo. So I would hand it over to Great at this point to show us what our Packer and Terraform looks like.
Okay. Hello. Hi everyone. My name is Great. I'm currently a software engineer teaching same at games. And yeah, I'll be giving a demo on this stuff. So yeah, we'll just go straight ahead. So I'll just get to the code and um, try to explain a few things. So yeah, like in the introduction previously, we had an introduction to what Packer looks like. So that is where I'm going to start from. In this images folder, we have the template.json, which is a Packer definition file. Packer is like a tool to build machine images that could be used across platforms. So building machine images with Packer, you have the builder section, which uses a source AMI and which uses a source AMI, and then you have which uses a source AMI, and you have the region define the AMI to be used, and also some configurations here. It also specifies the EC2 instance type and also the SSH name to use. So when these AMIs are built, they are defined with a name. So yeah, we define this AMI as HashiCorp Africa, and also added a timestamp to it. Then we also have the provisional section where we are copying this app directory. Yeah, I'll come to this app. We're copying this app directory into the machine image in this destination home user. And we also have the shell which executes the Packer script. So yeah, I'm going to come to this boot. Yeah, let's look at our sample application. We just have something very simple that looks like what goes on day to day. Because you have a simple app to create entries, get to the entries, and also get the entries. So yeah, this code is available on the repo, so you can just have a look at what this simple app do, and also use the SQLite DB. So yeah, let's have a look at the Packer SH5. By installing this is a Golang app, so by installing Golang, we're building a Golang app, putting it into the local directory, and also um, creating a system um, MD file to like put it to start the application really quick on startup. So yeah, let's talk about the advantages of using Packer. So with all these steps are like kind of pre-configured. So this means that any failure, we get to see any failure before it actually happens. So we get to see any failure before it actually goes to deployment. That's one reason I like Packer a lot because just like continuous integration, we have a really good feedback on what might happen before we deploy. So I'll just give a sample of what a Packer output is. This takes a lot of time. It takes some time. This build was 9 minutes, 22 seconds. So I had to build it before the demo. So yeah, these are the steps. These are the steps here. It does the provisioning with the shell scripts. um, does all we say, install Golang, install the rest, put everything into place, and create the system ND service, and the rest of all that. All these are done like pre-configured. All we just have to do is to deploy this machine image, and we get exactly what we want. We get the application running. So let's take note of this AMI name, AMI 06. It ends with a tray 5. Um, so yeah, then we could also talk about Terraform. So Terraform is um, an IAC, infrastructure as code tool, that allows us to deploy resources to different cloud environments, different Docker, a lot of environments. So Terraform works by using providers. For this demo, we are using the AWS provider. Um, right here, we define a security group. So this security group is opening port 8080 for Ingress and also port 80 for Ingress, the HTTP ports. And also we have the SSH. So just in case we need to SSH into the instance, I will also have the egress defined. So remember that we named we built our Packer image with this AMI name. So we are just using the data script here to look for the most recent AMI with this name. So it checks the timestamp and gets the AMI with this name. And we have this section here which deploys the AMI. The instance type is defined, the key name, and the rest of all this is defined here. So why don't we leave it off and try to see how um, Terraform helps us in this case. So we could just run a Terraform plan. Okay, so I'll just ls so you see that these files are here. The reason you see a TF state file and a TF state backup file here is because I had run this program before, like before the demo. Um, Terraform creates this file. So on the normal day, you have to run Terraform init on a fresh repo, but I don't have to run that now because I've done that beforehand. So to just run the Terraform apply or Terraform plan, so we see beforehand what is going to happen. So expectedly, what we are watching out is to see Terraform deploy this AMI that was built by Packer. So this AMI here matches this AMI name here. So that is great. So we could just go ahead and run Terraform apply. So we say yes. So now, what Terraform is doing now is kind of creating the resources, it's creating the security group, and also creating the um, app instance. So, like I said before, one why I really like using Packer is on a normal day, okay, you just put these scripts, put all these operations into your user data file, into user data. And what user data does is that it runs on init. Once the machine is deployed, the user data runs, and that could take minutes, hours. Just imagine an application that has a lot of dependencies. That could take minutes and hours for like this application to be ready. that is for readiness. But with Packer, we could just bundle big everything beforehand. All we just have to do is to just deploy that AMI, and we have our application starting up immediately. So we just have a look at this. Okay, so this is deployed now. Two resources are there, zero change, zero destroy. So we could have a look at the app that was deployed. Uh, in US East 1. Oh, I'm on US East 2. So we just have to change the region. It's not quick enough. How is this not coming up very fast? Okay, so yeah, we have this app server deployed. It's still initializing, and you can see that this application is ready because it has already deployed to the AMI. So we could confirm that, confirm to see which AMI. Remember, this ended with 335, so it has deployed this AMI. So why don't we test the app? I just use Postman. I test the app and see, yeah, because it's supposed to test the app. Replace this here. So right now we have zero entries. Why don't we put an entry? Okay, so we say create. That was quite fast, right? Like getting our app ready. So we say entries. We should get all the entries. Yeah, this is a list of my favorite rappers, hip hop rappers. So it gets the list of all that. So yeah, so as a recap, as part of a recap of what we just did here. So we use IAC. IAC is ensure that we have a reproducible and consistent environment. We could also put our ICs also make sure that we could also put our infrastructure as code into version control like it to ensure that we have different versions and to ensure that we are consistent with what we are building. I will also use Packer. Packer is a tool that creates machine images and does the whole pre-configuration beforehand. All we just have to do is to deploy that AMI and a machine image or AMI and to make sure um, to make sure that our applications start up really quickly. So these are some ways to build really consistent infrastructures with this boot tooling. So yeah, that's the end of the demo, and I will look forward to your questions. Um,
All right then. Thank you very much. So with that said, that's the end of the session. But a few things before we go. If you are looking for the links to the slides and the code, they will be at these URLs on screen. You can find me at Syntax Error, the Bird app, same with Grid, and our respective emails are in the slide on screen currently. But yeah, as a final note, again, the idea here is being able to reduce the number of surprises you have when you deploy your infrastructure. And our choice of tools were Terraform and Packer in this case, but it might look different for you. So the idea again is being able to reduce the number of surprises by leveraging tools that would give you this kind of output. And again, whenever you build infrastructure, try and write some documentation just so the new guy, whoever it is, would not have to scramble around trying to figure out what's going on. And in the long run, you can save people a lot of pain. So thank you very much. and enjoy the rest of the talks.
Okay, thank you very much too. And sure, enjoy the rest of the talks. See you soon. Bye.
Bye.